Hey guys, I'm just here at the library. I'm just enjoying my day. I just did my lab exam. What was that?
What happened to Joycelyn?
I don't know, she just passed out.
It's probably because she needs a buffer solution.
What's that?
Okay, so a buffer solution is basically a solution that contains a weak acid and a various base, or a solution that contains a weak base and a various acid, and an example of this is human blood. Its purpose is to act as a resistor to possible changes in pH with an added solute. It's able to resist pH due to the equilibrium of the acid and the base, and when there is a larger quantity of hydrogen ions added, the equilibrium is shifted to the left, causing this concentration to increase by less than the expected amount of the acid. However, when there is a larger quantity of strong base in the mixture, the hydrogen ion concentration decreases by less than the expected amount of base, meaning the equilibrium is shifted to the right because of the loss of hydrogen ions in the reaction. And this is shown in the balanced reaction with the base and the acid, and it's important towards biological applications, for example, ensuring the functioning of proteins. Please cut that out. What do you think, Leslie?
Well, I think buffer solutions are extremely important for human health. Our blood itself can be a buffer solution. Buffer solutions are so important for our health because they help in the adjustment of the nature of our blood. Reactions will happen in the plasma of our blood, but these reactions will fail to happen if the pH changes. These changes in pH may have an effect on our biological activity as human beings, but we have buffers to keep these changes from happening. If our pH value of blood is in either alkaline or acidic form, it may be harmful enough to lead to organ failure or death. Alkaline buffers are used when there is more acidic content of blood. It needs to mix with the plasma and neutralize the value of acidic buffers. And when the blood is alkaline, the opposite happens. These buffers are so important for our human health because if the alkalinity or the acidity of our blood pertains for long periods, it becomes hazardous, and when left untreated, may be fatal. Wait, Joycelyn, what happened to you?
I got a blood transfusion. Yeah, so while I was at the hospital, the doctors told me that the buffer effectively neutralizes added acids and bases while maintaining a relatively constant pH, and it uses carbonic acid and bicarbonate found in blood to keep the pH level at 7.4. The bicarbonate neutralizes excess acids in the blood, while the carbonic acid neutralizes excess bases. When buffer is added, the pH level can change by either -1 when acid is added or by +1 when a base is added before the pH begins to change significantly. After the addition of base to raise the pH by 1 or more, most of the conjugate acid will have been depleted to maintain a certain pH, so the pH will be free to increase faster without the restraint of the conjugate acid. The same goes for the addition of acid. Once the conjugate base has been used up, the pH will drop faster since most of the conjugate base has been used up.
So in fact, the buffer solution that maintains the pH of human blood consists of a combination of a carbonic acid, H2CO3, and bicarbonate ion, HCO3. When any acidic substance enters the bloodstream, the bicarbonate ions neutralize the hydronium ions, forming carbonic acid and water. Since carbonic acid is already a component of the buffering solution of blood, hydronium ions are removed, which prevents the pH of blood from becoming acidic. On the contrary, when any basic substance enters the bloodstream, carbonic acid reacts with the hydroxide ions, producing bicarbonate ions and water. Eventually, as bicarbonate ions are already a component of the buffer, the hydroxide ions are removed, preventing the pH of blood from becoming basic. So, the buffering mechanism plays a critical role in maintaining a constant pH of blood and turning Joycelyn's pH blood levels back to a constant level. So, if you want to see the equations for this chemical phenomenon, here it is.
If this video gets more than 4 likes, we'll give out 6.02 times 10 to the power of 23 glass stirring rods.